So I've got this DIY solar system, and in here I've got my Renogy 1000 watt inverter, 700 watt inverter, some Renogy MPPT chargers, and I've got these various connectors and studs, which are just some cheap Chinese studs that I found somewhere on eBay. And the wiring just looks like a mess, so I really need to fix up this wiring. And you can see it's just a complete mess. I might not be able to fix those up that easily up there. Those are just some bus bars up there. I picked up these Victron, a distributor and a Victron power in. And because the distributor doesn't come with fuses, I also picked up a bag of these Victron fuses. Now Victron is expensive, but they're also really nice, because I have already installed a set and I was very happy with them. So first things first, let's open these up. So this is the Lynx distributor. And I've already taken it out of its plastic little wrapper. They give you a sticker. That whirring sound was basically the sound of one of my refrigerators starting to draw extra power, so the inverter started whirring. I've seen current bursts as high as 130 amps from a refrigerator starting up, so that exceeds 1 kilowatt, but these 1 kilowatt Renogy inverters can go to 2 kilowatts briefly. So this is in case you need to mount this upside down and you want to relabel these somehow. So that's why they give you this sticker. But that's if you for some reason have to do it that way. I don't need to do it that way. Okay, so I brought some more tools here. Ratcheting socket set. I have wrapped some electrical tape around it, so in case this is connected to something and I touch something and I have for some reason forgotten to de-energize something, then it doesn't short circuit. Or if you're working on a battery terminals, it doesn't accidentally short circuit. Okay, these just open up. And these things actually pull out too, but these are useful to keep around and have inside. You have to tear off this plastic thing here when you install the cable. It's the Lynx distributor. Now, turns out of course the Lynx power in is nearly identical, with the only difference being the circuit board is not there, and the M8, there's some M8 bolts, extra M8 bolts and nuts and washers, but there's nothing else different. The actual fuse holders are actually the same. There's spots for fuse holders, even though there's no official spots for fuse holders in the Lynx power in. Made it cheaper for Victron to produce more of the same injection molded parts, rather than paying for molds for multiple parts. There you go. Virtually identical. The only difference is you have to undo these screws here and these screws here. If you do that, which I won't do here, this plastic thing comes off and you can actually install the extra M8 bolts through these 4 holes here. See, it's the actual same piece. And there's nothing under there. It's just the M8 bolts. And there's like a nut, some washers, and a nut on top. And the idea is that you put the fuse here. Okay, now I want to install my fuses. You can actually turn a Lynx power in into a Lynx distributor So I'm going to store one of these fuses for future use. I'm going to install it here. These are 250 amp fuses. They give you 5 in a bag, and you only need 4 for a distributor. So I'm thinking of using this to fuse my main battery. I have a lithium ion, a homebrew lithium ion battery, which has a fairly high current capability. So if it were to short, it would create a large current burst. So putting a 250 amp fuse there it'll definitely blow the fuse, but it'll be a safety mechanism. Normally you'd only put fuses on your distributor, but having them on your battery, or on each battery, depending on how many batteries you have, I'll basically have to buy more fuses. That's a safety mechanism. Okay, now it's time for ratcheting screwdriver in action. Let's see which one of these. This works with a little bit large. Okay. Yeah, I'm gonna have to use this one here. Okay. I have some electrical tape on the socket as well for the same reason. When working on batteries, it just reduces the odds of this hitting some random cable and creating a short. As far as my understanding is that this circuit board runs off 5 volts. If you just provide it 5 volts, then it would function. So you don't need to buy the shunt to power it. If you hack in 5 volts, I think you can just power it, but I'm not going to do that. Okay. And this is all it is. And now you would install your cable onto here and here instead of here and here like on the power in. There's basically nothing else to it. And for now, I'm not installing the cable, but I'm going to just finger tighten this end because my plan is to very shortly install cable. I'm also going to slightly loosen this one here so that it's ready, so I can disassemble it easily later. Because I'm intending to shortly install this on the wall. Okay, so now I've put in all the fuses, and I've got my one spare, which I'm going to eventually put inside this Lynx Power in. And now I'm going to close this up just because I want to just keep it clean, and I will then need to move some stuff on the wall before I mount this on the wall. Same thing here. I'm just going to close these up. These screws have some sort of retaining mechanism, so they're nice. They don't come out and get lost. And I'll need this. This is one of these pieces I was talking about. And if you have the Lynx shunt and you're using a 12-volt battery system, it'll light these up. But again, I think you can just hack in 5 volts into the circuit board and it'll probably run just fine. Okay, so here is my battery. The top, you can see the top of my battery and the various wires and the mess that I'm trying to clean up. And one of the things is I do not want this battery to be exposed. I want it to actually be protected. Because right now it's exposed in a dangerous fashion, so if a metal thing were to fall on it, it would short. So I'm going to build a casing for it. I'm also going to make it 2 levels. So this battery is going to go down there, where I currently have a single lead acid battery hiding down there. Instead, the big lithium ion battery is going down there. And then I will have a top shelf, and that lead acid is going to join the other lead acid batteries in that other array that I was talking about on the other Victron. Then I'm going to mount a similar size battery like this, which I haven't finished making yet, on top of this, roughly where this one is. And that is going to be a very large lithium battery, an array of 2 batteries that are going through this power in that will be fused. So each battery will have a 250 amp fuse, which may actually be too small. I may have to actually put in like a bigger fuse, like a 500 amp fuse. And then that will run a much larger inverter, and I will just run a lot more stuff off that one inverter. And then I'll just have a larger battery. And this will become a scalable battery because I could add more lithium ion batteries to it. Now, each battery has to have its own BMS. That's very important. So its cells have to be balanced internally within itself, and its BMS has to run that specific battery. You can't parallel lithium ion batteries together unless they're each are independently managed internally inside their parallelism. So I removed one of the 2 inverters. It was being fed by that lead acid battery down the bottom. And now I'm going to mount the Lynx Power in where it used to be. And then I'm going to start attaching the lithium ion battery to the Lynx Power in. So first I'm going to screw these screws. Lid. You have to remove the lid because of the screws. It needs some screws. And I have holes for the studs already, so I'm going to just put it where the studs are for these 2 screws, and these 2 screws will obviously not be able to go where a stud is because there's no stud. So I think that's going to be a good place. It's going to be a structural screw into the stud here. Just kind of tighten it by fingers there into the let's see if I can get it to go in straight. I'm gonna just temporarily put in a drywall screw here. There's no stud here. Probably need something to hold it in place. I put these other screws in. I'm going to get a bigger bit for the Phillips. Okay, I've got a bigger bit for the Phillips. This previous one was a little bit on the small side, making it hard to get a good grip on the screw when putting it into the stud. Okay, now that's in the studs really well on that side. Now I'm putting it in the non-stud side here. Just drywall screws. Okay, that is on very solidly. This is not going anywhere. So I can now start attaching battery unit cables to the bus. Okay, I have moved this inverter and that transfer switch over to that wall, so I've got space for a distributor. Now I'm going to install the Lynx distributor, and you're going to see it. Now in the previous clip I installed the fuses, which are separate, so there's not much to do this time around. I've got one spare fuse left, which I'm going to insert in the power in, because I'm going to hack the power in into a partial distributor. This is all a 12 volt system, well 16 volts, because it's actually a 4S LiPo, so there's no high voltages involved. But this bus system is capable of supporting much higher voltage batteries. I'm just sticking to the 12 to 16 volt range for safety reasons. So even if I touch bare energized metal, it doesn't really do anything. Whereas if you go to like 40 volts or 60 volts, it actually starts becoming dangerous. So with 12 volts, you have a much greater safety, because even if you touch energized metal, it's not going to shock you. So I'm now going to install this here. And now I need my socket set. Let's make sure you can see everything, see all the action. Yeah. In order to install this, I need to remove these rubber caps, because these will actually be what gets screwed into here. These come on the Lynx. And also you remove this plastic protector. And then this will get bolted in place here and screwed to the wall. So this will go like this. Now the circuit board is not being used because it's not powered. If you want to power it, you can give it 5 volts, either by buying the Lynx shunt or the Lithium Ion BMS if you're using their batteries. But I'm going to just use it as a dumb fuse holder slash strut, which is just fine as far as I'm concerned, because it's actually a good deal. Even just purely as a fuse holder and a bus, it's actually worth the money, because otherwise by the time you buy all the parts, you've spent about the same money anyway. So you can think, oh wow, it's so expensive, it's 140 bucks for the power in and 200 bucks plus a little change for the distributor. How can that possibly be a good deal? Well, that's because the distributor is also a fuse holder, and it's not just one bus, it's 2 buses. It's positive and negative, 1000 amps. And it's got a lot of it's like a protective plastic structure. So it's actually worth it if you study. By the time you get all the same equivalent parts, you actually have spent more if you were to try to penny pinch it and try to minimalistic buy pieces here and there. Now if you don't have a budget though, like you're just trying to slowly build up a solar system without a budget, then going for the individual piece parts works, because I'm just going to finger tighten this because I'm not actually attaching it yet. I need to get my screws, and then I will screw it in. Okay, got my screws. I had to actually tighten it. Finger tighten first. This is where the electrical tape on the handle comes in useful. Okay, now this Lynx Power In has battery and also all my chargers and things connected, but I actually want to transfer some of those, including the load, over. So I'm going to disconnect here. I'm going to disconnect this, disconnect the load. This is going to create some beeping unless I go to wall power. Okay, now disconnect. That's just the inverter complaining that it lost power. Now I'm going to disconnect all these solar panels, and you're going to see these all go into night mode. So I disconnect my various solar panels. Which I have 3 disconnects, because I have 3 arrays. Okay, so now all of my MPPTs are indicating the solar is disconnected, because I have now de-energized the charging lines, but the battery is still connected and the discharging line is also disconnected. So the battery is now the only thing connected to this bus bar. Everything else is just a wire that's going to some components that are off. So this is my battery lead, which is going to stay here. So now this inverter will be fused. It's a slow blow fuse because there will be some significant inrush current capability from the DC-DC converters in between, and also the capacitors in the inverter itself. So if you were to have a fast blow fuse here, even though it's high capacity, it might actually blow just because there might be unknown high current bursts that might exceed 250 amps for like a fraction of a second, like a small fraction of a second. And so even though in theory that's not supposed to happen, in reality that may actually happen. So a fast blow fuse might actually pop even though all the components are meant to draw less power, and even though the inverter is only a 1 kilowatt inverter, its capacitors for its inrush current might generate power bursts which are a couple kilowatts. So we don't really know what will happen there. So we want to slow blow fuses. The load is now, or at least the connector to the load is enabled, but the load itself is not connected. I can do that
through here. And you can hear it. So it's now running through here. The distributor is doing its job. Note that none of the solar is running, it's just the inverter and the battery. Now, the downside of the safety of the 12 volt system is that all your wires are super thick and you will spend a lot on wires. In fact, my wires cost as much as my solar panels, because everything has to be 4 gauge or 6 gauge, and in a few rare places you can have 8 gauge. So it's a lot of 4 gauge and 6 gauge, some 8 gauge. It's just much heavier duty wiring, much harder to work with. But safety benefits, as you can see, I'm just working without fear on these circuits because it's all 12 volts or 16 volts. It's not going to do anything to me if I touch it. Even if I touch both poles at the same time, it's not going to do anything. It's like I mean, I would have to really work on it, have to be sweaty, I'd have to have like bloody cuts. I would have to really work on it to try to make it pass a current through me. So you can see that the sun symbol has come on. It has not started charging because it takes a while for the MPPT to realize it's live. Now it's going to start sending current in. It's actually going to start actively charging the batteries, though nothing is going through yet. Again, it takes a while for it to realize that it needs to do something. In the meanwhile, I have 2 more channels to move over. Okay, I have now wired up the distributor on the right side. I've got 3 charging leads coming in and 1 load. This one has a black wire. It should be red, but it's black just because I had this connector with 2 black wires on it. So I will update that to a red wire later. I have to get more crimp pins for that particular connector. And so these are all running now and charging. The distributor, or the power in, has only the battery, and the distributor has all the loads and chargers. There's only 1 load and 3 chargers right now. This one later I will add another lithium ion battery to it, which currently is down here. That lithium ion battery doesn't belong there. It should be over here, tied in parallel to this one. Each battery will have its own BMS, so it's safe to parallelize them because they're BMS'd inside the parallelism. And then these guys then basically just run, gets charged from those and run that inverter, which runs these freezers and refrigerators here. When the refrigerators and freezers draw the batteries down below a certain set point, that automatic transfer switch will kick in and switch to wall power. But now I'm going to put the covers back on. I also transferred the plastic parts that still had their unused markers on them into this power in, into the 3 slots here that I'm not using. And this distributor, the lights don't glow because there's no 5 volts to the, there's no 5 volts from the shunt to energize that PCB. So you won't see the glow of the LEDs to indicate fuse blown because that circuitry won't be functional. But that's okay, I don't care about that circuitry. And if I ever did need it, I would just wire in a 5 volts into that circuit board. I don't actually know if the shunt actually supports non-12 volt battery systems because I don't want the lithium ion BMS because I don't want their batteries. because I'm going to use my own batteries. There, that looks much better than before. A little safer with less exposed wiring. And these are connectorized here with 50 amp Anderson connectors. These 50 amp Anderson connectors, each individual channel is less than 50 amps. So they can handle, these connectors can handle the individual channels. They get combined in this Lynx system. So technically there could be 150 amps flowing through those 350 amp connectors. But this is only a 20. I only have a 240s and a 20 for the MPPTs. So it's only 100 amps max through the MPPTs. And the fuses are only 250 amps. So the total power into the battery can't exceed 100 amps. Also, the BMS on the battery prevents more than 110 amps charging, or greater than 110 amps output, or it disconnects the battery. So the BMS limits it at 100 amps anyway, which is good. It's all roughly appropriately sized. The only thing that's off are the fact that the current shunts, the fuses are 250 amp fuses, and I suspect that the current bursts, transient current bursts, might be higher than that in some places. When like a refrigerator starts up, I've seen 110 amps come out of a refrigerator, or a refrigerator drawing 110 amps, even though it draws only 10 amps when it's running. And now finally I'm engaging the inverter. So now this is now battery powered, inverter powered through the shunts. So this is the new Lynx shunt. The wall looks cleaner than before. It's not done. I'm not done cleaning it up, but that helps quite a bit. The next step is that I'm going to put a protective cover on the batteries, and I'm going to combine 2 different lithium ion batteries down there. And that is the conclusion.